Hey guys, this is Ms. Hardison. I'm going to share a little bit of information with you on Lesson 9. So if you could, please pause if you do not already have your book turned to page 78 of your textbook. If you could, go ahead and pause, get that out so that we can get started with the lesson. Alright, so in grade 6 you learned about unit rates, so we're going to take a look at this problem. It says, and before we get started, I might want to add that anything that I write down is important and you should write it down too. This is a video, so if you need to pause it, you can pause it and then catch up with me and resume the video then. It's very possible that you might get a grade for these notes. I would hate for you to not get an easy grade because you were being lazy. So make sure you're copying everything down. Okay, Jana is training for a triathlon that includes a 112-mile bike ride. Today she rode her bike 12 miles in 45 minutes. What is Jana's rate in miles per hour? So you can see that they've made this number line here, and it's talking about the 12 miles is the total distance that she ran, and she ran it in 45 minutes. So if Jana biked at a constant rate, how many miles did she bike in the first 15 minutes? Well, look, it's broken down already for you in miles using this. So how many, look, they even changed the colors here. So this is 15 minutes. This is 15 minutes. And this is 15 minutes. So in the first 15 minutes, how many miles did she bike? Well, 1, 2, 3, 4. She biked 4 miles. At the same rate, how many miles did she bike in the next 15 minutes? 1, 2, 3, 4. Again, 4 miles. At the same rate, how many miles did she bike in the last 15 minutes? 1, 2, 3, 4. Well, it was split evenly, right? So it was 4 miles every 15 minutes, or 12 miles in the total 45 minutes. How many more minutes would Jana need to bike a total 1 hour? So she biked 45 minutes. There are 60 minutes in an hour, so how many more minutes would be needed in order for it to be an hour? So you would just say 60 minus 45, which gives you 15. So 15 more minutes. Okay, at the same rate, how many miles would she bike in that amount of time? Well, we've already looked and we saw that she bikes 4 miles in 15 minutes. So she would bike 4 miles. Explain how you could find the number of miles Jana bikes in 1 hour. So we know that there's 4 in each 15 minutes. So there's 4 groups of 15. So could you not just add 4 plus 4 plus 4 plus 4 and get 16? Or you could multiply, because you know there's 4 groups of 15, and in each of those 4 groups, in each of those groups, she biked 4 miles, so that would be a total of 16. Alright, go ahead and turn the page. The number of miles Jana bikes in 1 hour is a unit rate. This is a big deal, underline it. A unit rate compares 2 quantities where the second quantity is 1. So it's comparing 2 quantities, but the second quantity is a 1. A unit rate tells you how many units of the first quantity corresponds to 1 unit of the second quantity. Unit means 1, so this is where the 1 is coming in. The units in this problem are miles and hours. The problem tells you that Jana bikes 12 miles in 45 minutes. That's the same as 12 miles in 3.5 hours, or I'm sorry, in 3/4 of an hour. So the number of miles is on top of your fraction here, and then the number of hours is in the bottom. So 12 miles in 3/4 of an hour. The fraction 12 miles and 3/4 of an hour is a complex fraction. A complex fraction is a fraction where the numerator is a fraction and the denominator is a fraction, or both numerator and denominator are fractions. You can simplify a complex fraction by dividing, just as you would do if the numerator and denominator were the whole numbers. The fraction bar represents division, so you can think of 6 miles in 2 hours as 6 divided by 2, or 3 miles per hour. And this little division bar here would be the same thing as the word per. So if you want to put that there, anytime you see that, that's how you can find out what words to use over here, miles per hour. You can think of 12 divided by 3/4 hour in the same way. 12 divided by 3/4, simplify that as 12 over 1 divided by 3 over 4. In order to divide a fraction, yes, you could divide it, but the easier way is to multiply by the reciprocal. So 12 over 1, change the division sign to a multiplication sign, and multiply by the reciprocal. Remember, reciprocal just means opposite. So they did that, and they got sorry, 12 times 4 is 48, and 1 times 3 is 3. 48 divided by 3 is 16. That means that the unit rate is 16. The number of miles Jana bikes is 16 times the number of hours. Okay, let's look at this reflect now. On another training ride, Jana bikes 15 miles in 50 minutes. Explain how you could find the number of miles she bikes in 1 hour. Well, we have to first find out how many minutes 50 minutes is of an hour. So we know that there are 60 minutes in an hour, and that she is biking 50 of them. So we can take that and simplify it. So 50 over 60 would simplify to 5 over 6. So she is biking for 5/6 of an hour. That's how much 50 minutes is. It's 5/6 of an hour. So you would have 15 miles divided by 5/6 of the hour. This is a complex fraction, a fraction within a fraction. Once we get to this spot, we're going to divide. So then we divide. And again, you guys should have already dealt with dividing fractions. You know that you multiply by the reciprocal. So you have 15 over 1 divided by 5 over 6, which is the same thing as 15 over 1 times 6 over 5. Alright, so we can do the math. We can say 15 times 6, so just over here in the corner, 15 times 6. 6 times 5 is 30, 0, carry your 3. 6 times 1 is 6, plus 3 is 9. So 15 times 6 is 90, over 1 times 5 is 5. Now you have to divide this. Again, these are all fractions. So you have 90 divided by 5. 5 will go into 9 one time. 1 times 5 is 5. You subtract those. 9 minus 5 is 4. Bring down your 0. 5 will go into 48 times. 8 times 5 is 40. Again, all of this is review. We get 18. So if she was to bike the full hour, she would have gone 18 miles. That's what that's saying. 18 miles per hour. if she would have biked the full hour instead of just 50 minutes of it, she would have went 18 miles. All right, go ahead and turn to page 80. This is some real-world stuff here. It says, read the problem below, then explore different ways to understand how to find a unit rate. Oh, let's get this focused. All right. Max's favorite recipe for oatmeal raisin cookies makes 48 servings. He wants to make some cookies, but only has 1 egg. Max has to adjust the amounts of the other ingredients. How much flour will he need? So you can draw a double number line to show the relationship described in the problem. The units you need to compare the cups of flour and eggs. So cups of flour are on top, so for 0 cups of flour you need 0 eggs. Well, in the recipe it says that you need 2 eggs and 1.5 cups of flour. 2 eggs and 1.5 cups of flour. So here it's showing, okay, well at 2 eggs, you need 1.5 cups of flour. You need to find the unit rate, the number of cups needed for 1 egg. So we know how much is needed for 2, well in between 0 and 2 is 1. The point for 1 egg is halfway between 0 and 2. 1 is halfway between 0 and 2. Draw a line halfway between 0 and 2. They've already done that for you. The number line goes up with 1 is halfway between 0 and 1.5. So in order to find halfway between 0 and 1/2, you have to find half of 1.5. Okay, let's go on to the next page, but you will have to flip back to look at this chart for the next few questions. Okay, it says, why do you need to find the number that is halfway between 0 and 1.5? What's important about it? Okay, you're writing, remember. It is the amount of flour needed for 1 egg. Again, remember you're writing everything that I write. If you need to pause to catch up, please do so. So what is important about finding the middle of 0 and 1.5? Because it's the amount of flour that you need for the recipe to match for 1 egg. How could you find the number that is between 0 and 1.5? Well, how do you find anything that's halfway between it? You divide 1.5 by 2. Or, which will do the same thing, you multiply 1.5 by the reciprocal of 2, which is 1/2. Both of those will give you the same answer. So, how many cups of flour does Max need to use if he has just 1 egg? Show your work. So up here we said we could divide 1.5 by 2, which is the same thing as multiplying 1.5 by 1/2. So I'm going to show the work here. So 1.5 times 1/2. You guys cannot keep this mixed number here. You need to make it improper. And you make it improper by taking the denominator and multiplying it by the numerator. So 2 times 1 is 2. And then you add the numerator. 2 times, the denominator times the whole number. 2 times 1 is 2. Plus the numerator, which is 1. So 2 plus 1 is 3. 3 over 2 times 1 over 2. Then we can just multiply straight across. 3 times 1 is 3, and then 2 times 2 is 4. So that means that you need 3/4 cup of flour. if you only have one egg. Write the ratio that compares 1.5 cups of flour to 2 eggs. Okay, well, cups of flour, it's 1.5 to 2 eggs. Number 6, write and simplify a division expression to find the number of cups of flour Max needs to use if he has just 1 egg. So what we have is 1.5 cups of flour divided by 2, because it's 1.5 cups of flour and 2 eggs in the original equation. We have to make this into a mixed number. We've already done that in the previous problem. So 2 times 1 is 2, plus 1 is 3. So 3 over 2 divided by 2 over 1. And then it tells us that we need to, so that's simplified right there. So we can go ahead and solve it again. So 3 over 2 times 1 over 2. 3 times 1 is 3. 2 times 2 is 4. So it's 3/4 cups of flour. So it's just 2 different ways of looking at it. We did the same work there though. So that means that the unit rate is 3/4. So for 1 egg, you need 3/4 cups of flour. The unit rate for 1 egg is 3/4 cups of flour. The number of cups of flour is 3/4 times the number of eggs. So we need to explain how we found the unit rate. Why don't you go ahead and pause it and try to write down how we found this unit rate. Alright, so what you should have started out by saying is write a ratio, which is what this 1.5 divided by 2 is. It's a ratio. The ratio that compares the amounts in the problem. So the flour to the eggs. Then you divide, oops, the first number by the second number. Alright, then it gives us some problems down here. It says use the information in the recipe on the previous page. So on page 80, you're going to look back at it. It's this right here. I'm going to look back at it. And if Max has only 1 egg, how much butter will he need? Well, in the original recipe, how much butter is there? 3/4. Now, we're looking at butter first. How much butter will he need? So whatever they're asking for needs to be in the numerator. So the butter needs to be in the numerator. So it was 3/4 a cup of butter. If you look right here, butter was 3/4 of a cup. And then how many eggs were in the original problem? And it's okay for us to look at this way because we're wanting the unit rate of 1 egg. So in the original one, it was 2 eggs. So we're taking the original problem. It took 3/4 cups of butter and 2 eggs. So now this is a complex fraction. We need to simplify it. So it would be, this equals 3/4 divided by 2 over 1, which is the same thing as 3/4 times 2 over 1. Again, you just multiply across. 3 times 2 is 6, and I'm sorry, I did not flip that. So go back. I showed dividing by 2 over 1. Well, whenever you multiply, you have to multiply by the reciprocal, and I missed that. I'm sorry. So you're going to multiply by 1 over 2. Give it a second to catch up. Come on. All right, so 3/4 times 1/2. 3 times 1 is 3, and then 4 times 2 is 8. Now, that means that there's 3/8 of a cup of butter needed if there is just 1 egg. So we're making a complex fraction, and then we're simplifying it. Again, the simplifying part should be the review. You just need to focus on how to set it up. So number 10 says, if Max has only 1 cup of flour, how much vanilla will he need? So look at the original recipe again, and it says it's asking for vanilla. So it needs 1 teaspoon of vanilla, and then flour. So we're looking for flour to be the unit rate. He only has 1 cup of flour, so we want that to be the unit rate. So we know flour has to be in the denominator, because when we talked about unit rate a second ago, we said the unit is in the denominator. The flour, it shows here, is 1.5 cups right here. So 1 and then over 1.5. Whatever they're asking the unit rate for goes in the denominator. Whatever you have 1 of goes in the denominator. Again, this is a complex fraction, which means we have to say 1 divided by, let's go ahead and make this into a mixed number. 2 times 1 is 2, plus 1 is 3 over 2. And then we can just go ahead and multiply it. We have to multiply by the reciprocal. So instead of dividing by 3 over 2, we're going to multiply by 2 over 3. 1 times 2 is 2. 1 times 3 is 3. So that means that it's 2/3 a teaspoon of vanilla. All right. Go ahead and flip the page. We're going to look at page 82. Okay, so this is comparing unit rates still. It says Jose's mother is trying to decide whether or not she should buy 12-ounce package of coffee on sale for $7.50. She knows that she can buy the same coffee for $9 per pound. Which is the better buy? So again, this is a real-world application to this. This is whenever people go grocery shopping, they try to find, okay, well, which brand of green beans or which brand of coffee in this case will give me more for my money, so it costs less per pound or per ounce, whatever unit they're using. You can draw a double number line to show the relationship described in the problem. To find the better buy, compare the unit rate of each option. The problem gives you 1 unit rate. So it already has given you 1 unit rate. You only have to find the other one. To compare the unit rates, the units you use must be the same. Underline that. That is huge. To compare the unit rates, the units you use must be the same. Underline that. That is where they're going to get you on TCAP. They are going to make it where the units aren't the same. And that's what this problem does. So find the weight of the other coffee in pounds. So the first one that we had, or the one that was already done in unit rate, was $9 per pound. The other one that we had was a 12-ounce package. So you have to go ahead and make it be where it would compare in pounds. So there's 16 ounces in 1 pound. So 12 out of 16. Where they're getting this is the first package up here was a 12-ounce package. But we want to look at it instead of ounces in pounds. So we have to find out how much of a pound 12 ounces is. So they're taking 12 and putting it over the 16 ounces that is 1 pound. So 12 divided by 16, it simplifies, 12 over 16 simplifies to 3/4 of a pound. You can write $7.50 using fractions in the same way, $7.50. 0.50 is the same thing as 1/2. Either way will be fine. It's just easier to multiply. I guess they do want you to keep it in fractions because it'll be easier to multiply. Okay, so again, we're starting both number lines off at 0. So the cost in dollars versus the cost, or the pounds of coffee. So we knew 3/4 of a pound, which we found up here. 3/4 of a pound was $7.50. And so they've broken it down into fourths. It says divide the bottom number line into fourths, which is what they did. Line up 3/4 of a pound of coffee with the cost $7.50. We're lining those up because that's what it told us it cost. So find X, which would be the cost for 1 pound. We want to compare. We know that it's $9 per pound for this one coffee. How much would this one be if it was 1 pound? So here they said find the cost for each 1/4 pound of coffee and then find the unit rate. So for each 1/4 pound they're saying it's 2.5. So for 1/2 of a pound it's $5, then $7.50, then $10. All right, turn the page. The top number line is divided into 3 equal parts from 0 to 7.5. And the bottom number line is divided into 3 equal parts from 0 to 3/4. How can you use this to find the cost of 1 pound of coffee? So first of all, you had to divide 7.5 by 3 to find the length of each part. So each little fourth, we found out what it was by dividing 7.5 by 3. Or 7.5, 2 times 7 is 14, plus 1 is 15. So 15 halves divided by, make 3 into a fraction, so 3/1. We know that in order to divide these, we really multiply by the reciprocal. So instead of dividing by 3/1, we're going to multiply by 1/3. 15 times 1 is 15. And then 2 times 3 is 6. And you can go ahead and simplify this, make it into a mixed number. 6 will go into 15 2 times with 3 left over, so 3 6. 3 6 will then simplify to 2.5. Okay. So then to get the number, that lines up with 1, you will need 4 of these 2.5 parts. which is what they showed you in this picture. They showed you, okay, well, each section here is 2.5, so you need 4 of them. 1, 2, 3, 4 to make it to 1 pound. All right, so write the ratio that compares $7.50 to 3/4 pounds of coffee. Money goes on top. Always, always, always. Money goes on top. So 7.5, and then pounds of coffee was 3/4 of a pound. Again, this is a complex fraction. A complex fraction is a fraction within a fraction. Write and simplify a division expression to find the cost of 1 pound of coffee. So we have this division here. So 7.5 divided by 3/4. So the first thing we have to do is we have to change this mixed number into an improper fraction. 2 times 7 is 14, plus 1 is 15, and you keep the denominator. So the first step was to change the mixed number into an improper fraction. Now we can go ahead and divide this, but we have to multiply it by the reciprocal. That's the easiest way. So 15 over 2 times 4 over 3. So 15 times 4 is 60, and then 2 times 3 is 6. We have 60 divided by 6. 6 will go into 60 10 times. So that means it is $10 per pound. Which is the better buy? 12 ounces for $7.50 or 1 pound for $9? So this one was 1 pound for $9. How much was it for 1 pound of the other one? Well, we just found that it was $10. So they want us, this book wants us to do a lot of explaining, so we're going to explain it. The other package, which was the 12-ounce package, the 12-ounce package is $10 per pound. And the other one is the 1 pound, 1 lb, and the 1 pound package for $9. $9. So which one is the better buy? Would you rather spend $10 for a pound or $9 for a pound? And remember, it's comparing the pounds. Even though this package is less than a pound, if it were a pound, which one would be the better buy? Well, it would be the $9. So the better buy, and you'll hear that a lot when you're talking about unit rate. The better buy is the $9 package. If you started the problem by converting 1 pound to 16 ounces, would you get the same result? Justify your answer. So yes, you would, because remember when we started this, we said you have to have the same unit. So yes, because 16 ounces is equal to 1 pound. But both rates would need to be in ounces. So a main thing here is going to be making sure that The units are the same, so you got to have pounds and ounces. They got to be the same, so either both pounds or both ounces. Or if you're dealing with minutes and hours, they either both have to be minutes or they both have to be hours. You have to make sure that you change them. So can you compare any two unit rates? Can you compare any two of them? Well, we just talked about what has to be the same. The unit rates have to be the same. So no, you can't compare any two of them. No, the rates must be the same unit to compare. Again, put a star. You cannot compare minutes to hours or ounces to pounds. Okay, let's do this try it down here. Rena's recipe uses 2 cups of sugar to make 2½ dozen cookies. Jonah's recipe uses 2 1/4 cups of sugar to make 3 dozen cookies. Which recipe uses more sugar for a dozen of cookies? Why? So first we'll look at Rena's. So hers uses, which uses more sugar for 1 dozen. So we want the dozen to be the unit rate. So that means that the dozen cookies is going to be put in the denominator. So you got to look to see for a dozen of cookies. This is what we want to be our unit rate. So it goes in the denominator. So we're going to put the cups of sugar on top. And then we're going to have our fraction. And then how many dozen does the 2 cups make? 2 1/2. And so this is a complex fraction. Again, we got to change it to where it's 2/1 divided by, and then this mixed number here, make it into an improper fraction. 2 times 2 is 4, plus 1 is 5. So 5/2. To actually solve the problem, you have to multiply by the reciprocal. So 2/1 times, instead of 5/2, you're going to put 2/5. 2 times 2 is 4, and then 1 times 5 is 5. So Rena's would be 4/5. And so now let's look at Jonah's. Again, we're putting the cookies, the amount of cookies in the denominator. His recipe uses 2 1/4, so 2 1/4 is going to be in the numerator, and then in the denominator it's going to be how many dozen cookies it makes, so 3. Again, a complex fraction, so let's go ahead and simplify this down a little bit. Make the mixed number into a improper fraction. 4 times 2 is 8, plus 1 is 9. So we have 9/4 divided by 3. So 3 is a fraction, is 3/1. Excuse me. To simplify this another step, or to solve it, we will multiply by the reciprocal. So instead of 3/1, it'll be 1/3. 9 times 1 is 9, and then 4 times 3 is 12. Now this is a fraction that can be simplified further. 9/12. 3 will go into both of those numbers. So 3 will go into 3 will go into 9 3 times, and 3 will go into 12 4 times. So it says, which recipe uses more sugar for a dozen of cookies? Well, Rena's uses 4/5 and Jonah's uses 3/4. So which one is greater? 4/5. So Rena's because 4/5 is greater than 3/4. Okay, we're going to do one more problem, and then I'm going to leave you working on page 85 to 87. Okay, so there's only a few questions on there. I'm going to work this one with you, and then you can work on 85 to 87. Alexis washes 10.5 windows in 3/4 of an hour. At this rate, how many windows can she wash in 1 hour? So we have the time is going to be the unit rate, so we need to make sure that the 3/4 hour is in the denominator. So we have 10.5 divided by 3/4 of an hour. A complex fraction. We have to simplify it. So we take our mixed number, turn it to an improper fraction. 2 times 10 is 20, plus 1 is 21/2, divided by our 3/4. To solve this, we multiply by the reciprocal. So 21/2 times 4/3. We can just do the math over here. 21 times 4. 4 times 1 is 4. 4 times 2 is 8. So we have 84, and then 2 times 3 is 6. Now we have to simplify this. We can't leave it improper like this. So we take 84, divide it by 6. 6 will go into 8 one time. 1 times 6 is 6. Subtract them. 8 minus 6 is 2. Bring down your 4. 6 will go into 24 14 times, and that is 24. So we know that in 1 hour, if she washed windows for 1 hour, then she would wash 14 windows. 14 windows in 1 hour. All right, again, if you need to go back and look at any of this, please do so. You have some homework, I think, assigned. You should ask the substitute teacher. She might be able to give you that information. If you do have homework, do not do 85 through 87, but if you do not, please do that. Thank you, guys. Look forward to seeing you in 8th grade.